Hi everyone, welcome back to my channel. My name is Arinichi, and today we will go to the tutorial of the smart contract here. And in the last substrate, you will go to the tutorial here and develop smart contracts here. Yeah, and we go to the first things of this program is prepare your first smart contract. Yeah, as you learn in the blockchain basis, decentralized applications are most often written as the smart contracts. Although substrate is primarily a framework and toolkit for building custom smart contracts, it can also provide a platform for smart contracts. This tutorial demonstrates how to build a basic smart contract to run on a substrate-based chain. In this tutorial, you will explore using Ink as a programming language for writing Rust-based smart contracts. So before you begin, you ensure to have a good internet connection and access the shell terminal on your local computer. And you are generally familiar with software development and using command line interfaces. And also you are generally familiar with blockchains and smart contract platforms. So last one, you have installed Rust and set up your development environment as described in install. So we have a tutorial objectives here, and after this tutorial you will accomplish the following objectives here is learn how to create a smart contract project, build and test smart contract using Ink smart contract language, and deploy a smart contract on a local substrate node, and you can interact with the smart contract through the browser. Now you can update your Rust environment. And first one, open your terminal shell on the computer. I will open that by go to terminal here. You can also find the CMD also. Now you change the root directory where you compile substrate node template. Yeah, I will go to the folder of substrate node template. Substrate node template. See, substrate node template. Yeah, and I will update the Rust environment by this command here. Okay, I will copy that and paste here and run. Yeah, Rust LRC is up to date. So I will verify the WebAssembly target installed by this command. I copy here. Yeah, this is up to date here, and next I will install the substrate contracts node. To simplify this tutorial, you can download the pre-compiled substrate node for Linux or Mac OS. So the pre-compiled binary includes the frame palette for smart contracts by default. Alternatively, you can build a pre-configured contracts node manually by running curl install contracts node on your local computer. So now we can go to install it by step by step here. You can open the release page this page here. Also by okay, we will see the version of the parenthesis slowly here. Okay, I will go to the next step. Download the appropriate compressive achieved for the local computer. Okay, I will download this here. Download for the Linux. Okay, I will download this. Okay, I downloaded this before, so I go to the file here. Yeah, you can see. Yeah, this is a substrate, no contract. Contract no, version 0.17 0. Okay, what that is 0.20 0. Okay, that's no problem. So the next step, I will open the downloaded file and extract the contents to working directory. Okay, I will extract here. Okay, with that. It is dash file. Okay. So you can also clone this code by the cargo install contrast node by this command. So as the next step, we will install the additional packages. After compiling the contrast node package, you need to install 2 additional packages. So the WebAssembly Brian package for your operating system to optimize the WebAssembly by encode for the contract. The cargo contract command line interface you will use to set up the smart contract projects. So now we will install the WebAssembly optimizer. Now we open the terminal shell on the computer. Oh well, what's the root? So next step, you use the appropriate package manager for your operating system to install the package. Okay, I will use Ubuntu OS, so I copy that command and paste here. And password, that's password. No. Yeah. Okay, I will escape. No. Okay. Now we will install the cargo contract package. After you install the WebAssembly Brian package, you can install the cargo contract package. The cargo contract package provides the command line interface for working with smart contracts using Ink language. So now we open the terminal shell and install the giant link require linting contrast warning you about things like using ABS in the way that could lead to security issues. I will install the dialing here. So wait for a minute. Okay, after you install the dialink, you go to install the card contract by running this command. Yeah, I will paste here. Oh, that's so anyway. Yeah, okay, I just installed the card contract by this command, and now you can verify the installation and explore the commands available by running the following command. Yeah. It will give you some help of the command, such as the 8, its help its VS version, and some sub commands here. Yeah. And now we go to create a smart contract project. You are now ready to start developing the new smart contract project. To generate the files for smart contract project, you will open the terminal shell on your computer. Now you will create a new project folder named Flipper. Yeah, the project is created. Now we will change the new project folder by running the following command: cd the flipper. Now we can list all the contents of directory by running the following ls al. Yeah, like another Rust projects, the cargo.tom file is used to provide package dependencies and configuration information. The librsf file is used for smart contract business logic. Okay, we will go to explore the default project files. By default, creating a new smart contract project generates some template source code for a very simple contract that one function flip that changes the boolean variable from true to false, and a second function get that gets the current value of the boolean. The librs file also contains two functions for testing that contract works as expected. Now we can go to step 1. Open the terminal shell and go to the Flipper folder, and we can open the cargo.tom file. Yeah, I will go to it by the Visual Code. Now we go to the folder Flipper. Flipper here. That is. Okay, we go to the cargo time file here. Yeah. Now in the dependencies section, modify the scale and scale info settings if necessary. Now we can see the scale. I will make it small to see. Now we can see the scale. Yeah, scale here. Package is a parity scale code. Version is 3 and default features. Default features is false and features derived. Now you can see the scale info is version 2, default feature false and feature derived, and the optional is true. Yeah. Now open the librs file and view functions defined for this contract. Now we can test the default contract. At the bottom of the librs code file, there are simple test cases to verify functionality of the contract. You can test whether this code is functioning as expected using the uptrain test environment. You can see the test here. Yeah. Okay, this test come here. Okay, use the test sub command and likely to train to execute default test. This is for the sleeper contract by running the following command. Yeah, the programming is running and you can see your test is pass or the fail. Okay, after that you can get a result, okay, 2 pass and 0 fail. So now you can build the contract by this command here. Paste here and run. Yeah, after you compile the Flipper smart contract, you can see that the debug mode, the contract artifacts are ready, and you can try them in this link. Okay, the metadata station file in the target Inc. directory describes all the interfaces that you can use to interact with this contract. This file contains several important sections. The spec section includes the information about the functions like contractors and messages that can be called, the events that are emitted, and any documentation that can be displayed. This section also includes the selector field that contains the 4-byte hash of the function name and is used to route contract calls the correct functions. The storage section defines all the storage items managed by contract and how to access them. The types section provides the custom data types used throughout the rest of the JSON. Now we can start the substrate smart contracts node. Yeah. Okay, start the contracts node in the local development mode. You can copy that and paste here. Okay. Yeah, the node is running. Okay, to interact with the blockchain, you need to connect this node with the contracts UI. Now I open the link here. Okay. Now I will deploy the contract. At this point, you can complete following step. Install the packages for the local development. Generate the WebAssembly binary for the Flipper smart contract. Start the local node in the development mode and connected the local node to the contract's UI front end. The next step is deploy the Flipper contract on your substrate chain. However, deploying the smart contract on the substrate is a little different than deploying the traditional smart contract platforms. For most smart contract platforms, you must deploy the completely new block of the smart contract source code each time you make a change. For example, the standard ERC20 token has been deployed to Ethereum thousands of times, even if the change is minimal or only affects some initial configuration setting. Each change requires the full redevelopment of the code. Each smart contract instance consumes blockchain resources equivalent to full contract source code, even if no code was actually changed. In Substrate, the contract development process is split into two steps. Upload the contract to the blockchain and create instance of the contract. With this pattern, you can store the code for a smart contract, like the ERC20 standard on the blockchain once, then instantiate it any number of times. You don't need to reload the same source code repeatedly, so your smart contract doesn't consume unnecessary resources on the blockchain. Now we go to the upload the contract code. For this tutorial, you use the contracts UI front end to deploy the Flipper contract on substrate chain. To upload the smart contract source code, we go to the contract UI web browser here. Yeah. And connect to the local code. Yeah. And click add a new contract. Yeah. code now. And add new contract. So you click upload new contract code. Yeah. And select the account to use create contract instance. You can select any existing account, including the predefined account such as Alice. Now I use the Alice here. So type a descriptive name for the smart contract. For example, Flipper contract. I will get the name like this. Flipper default first contract. And browse and select or drop the Flipper contract file contains blended forms block and metadata into the upload section. Okay, I will open this folder. Save all. Now go to the Flipper folder. Here, Flipper. Here, yeah. And go to the target. You can see the ink giant. Okay. Now I will drag and drop the Flipper contract. Yeah. Flipper contract to upload folder. Yeah. And click next to continue. Now we create an instance on the blockchain. Smart contract as an extension of the account system on the substrate blockchain. When you create an instance of this smart contract, substrate creates a new account ID to store any balance managed by smart contract and to allow you to interact with the contract. After you upload the smart contract and click next, the contract UI displays information about the content of the smart contract. Now we create the instance. First one, you review and accept the deployment constructor options for initial version of smart contract. Now you can see some information here. Init value and deployment sort and max gas allowed. Now you can see the max gas allowed and fix this. Yeah, you click the use custom, maybe, yes, and fix it to the 200,000. 200,000. Now you click next. The storage No one is starting. Now the transaction is now quick. If you needed to make changes, you could click go back to modify the input. Then you click the upload and instantiate. Depending on the account you use, you might prompt for the account password. If you use a predefined account, you won't need to provide a password. Okay, I will upload and initiate. Success. Yeah. Okay. It's important. Okay, now you can call the smart contract. Now that your contract has been deployed on the blockchain, you can interact with it. The default Flipper smart contract has two functions, flip and get. And you can use contracts UI to try them out. Now go to the get function. You set the initial value of the Flipper contract value to false when you instantiate the contract. You can use the get function to verify the current value is false. To test the get function, now select any account from the account list. I will choose the Alice. Now go to this message to send is get. And click read. Now it is false. You can see it's false, and you can go to the flip function to change the value from false to true. Now do it by select any predefined account from the account list and flip function. It's transaction that changes the train state and requires an account with funds to be used to execute the call. Therefore, you should select an account that has predefined account balance, such as the Alice account, and select flip from the message to send this. Flip. Now you can click call. Yeah. You can see is make a new block and now go to get function to test the value. Okay, I will change it to get and break. Now look at that, the value is true. Okay, it's the value after executing the call. Okay, that's the first smart contract by substrate. And thank you for watching and see you in the next time. Goodbye.